Thank you, everybody. Thank you to the organizers for inviting me to speak, Pavel, Elena, and Ulf, and everybody else for coming out here today. So, my background is in systems ecology, and so I'm going to use that as a starting off point, but I'm really interested in systems thinking more generally, and so I'll also touch on some of the people that have influenced me throughout the years in a wide range of different fields, and hopefully there's something that you also find insightful in this. Well, recently I heard this story where there's this little English boy, 9 or 10 years old, and he's talking to his father, and he says, "Father, is it true that fathers know more than their sons?" And the dad, wanting to maintain his authority and his guiding principles, he said, "Yes, son, that is true. The fathers know more than their sons." And so he's thinking about it, and "Father, who invented the steam engine?" Father says, "Well, that was James Watt." And the boy replies, "Why didn't James Watt's father invent the steam engine?" So we know in the sciences work a little bit differently than parenting, because we all have our systems thinking giants that are out there. And these are a few of mine, and I didn't put names on them, so maybe you'll recognize a few of them. But science builds on the shoulders of the ones that have come before us. So we're fortunate to be able to have so many great, deep, insightful minds to choose and to work from in systems thinking, because we know that we really do need a new paradigm. Right? So we're dealing with these environmental problems. They're complex. They are many times irreversible. They are systemic. As we've talked about many times today, they can't be understood in isolation. They are interconnected and they're interdependent. And it might be that the solutions could be quite simple, and we can talk about that more if that's really the case or not, but I think one thing that is necessary is this radical shift in our perceptions, our thinking, and our values. So what has science done really well in the past? Science has done really well with the simple and the complex. So simple causality. For several centuries now we have Newton's laws of physics, and we can deal with the interactions of simple particles. And we also do well if there's many particles interacting in a disorganized fashion. So disorganized complexity and our understanding of using statistics for that. But what we don't do very well with is with ordered complexity. And living systems fall into this range of ordered complexity. And I think we do need new methods, and we need new dialogue and new understanding of how to deal with complex adaptive systems that Simon was talking about earlier today. So it's this rise of systems thinking that goes from the parts to the wholes. And two key properties of that are that we're really dealing with relationships between these parts, and then understanding that within the context of the larger whole. And using networks as one of the organizing principles of this is that we think of the web of life actually consisting of networks within networks. We've heard of systems already today as well. And then really to understand life will be to understand these networks. One of the things that intrigues me too is this whole idea of systems theory, and I came across this quote that really kind of made me think twice about this. The idea that systems theory is strictly speaking not a theory of systems, but of system-environment distinctions. So what we first have to do is we have to set up what is our system. We have to set up a boundary and a context for that system. And we typically take this very simple us versus them mentality, right? So there's the system and then there's everything else, and everything else is the environment. And so we immediately partition ourselves away from the environment and isolate that system. And we recognize that that's necessary in one hand because, as this says, that the realization of the system, a necessary condition, is the environment. So we need to have some sort of separation. And at the same time, it's by constructing that system also makes an understanding the environment, right? So it works both ways there. So that boundary does form a necessary condition. But I think it's more useful to think of it in terms of that system boundary being scalable, right? So in this image, what I'm trying to convey is that if we enlarge a system boundary, so we still have an environment that is out there somewhere, but within that system boundary, we have now parts of the system which can interact in a way that we can apply systems analysis and actually understand how the system is functioning. And we recognize that there's now two environments that we're dealing with, not just one. We're dealing with an input environment, you could say, and then also an output environment. And within that system boundary, we now have complete knowledge of the input environment and the output environment, as well as all the feedbacks that might take place within that. So any one focal entity now actually gets lost. I've highlighted one, but really the focal entity is just one among many that is continually interacting with the others that is in that network. But the network analysis allows us to identify the role and the influences that each of those has on each other one. And as Gregory Bateson once said, we live in a world that is made up of relationships. So we need to understand the relationships, not just the parts, but we need to understand the connections and relations. Okay, coming back to a little bit of Chinese philosophy and the different ways of thinking that we have. In the West, again, typically we've looked at explanation basis on causality, where Chinese tradition oftentimes focuses more on the relationships and gives priority to those relations. So why was this? Why was Greek thought so concerned with extricating being from becoming, where in China the only reality was change itself? And the difference, really stemming from several thousand years ago, and what has preceded since then, was that the difference in the Greek thought introduced order into becoming from the outside. There was some external agent, some causative agent that was providing that order to come about, whereas in Chinese thought, order is conceived from lying within the becoming. It is the becoming that is the process, right? So it's this difference very fundamentally, and in some ways the Eastern ways of viewing things are more in line with the systems thinking and the focus on context and relations. So again, if we focus on this duality, this subject-object system-environment duality that we have out there, then Aristotle actually declared these are two contrary principles. They cannot act upon each other. You have an object, you have a subject, and they are separate. They do not change into each other. They are mutually destructive, right? So in logical terms, these two things are actually mutually exclusive. Well, in contrast, the Chinese tradition insists that the contraries both oppose each other and contain each other mutually. So we all know this yin-yang philosophy as well as representation, and the idea here is that they both reciprocally give rise to each other's actualization, right? So the one is penetrating into the other one is opening up to the other one, and it's this continual relation that takes place there. Or as one cartoonist depicted it there, you see that you have the subject and the object, and it's not clear who the subject and the object is. Why is one the subject and the other one the object? It could be the other way around, as shown in the second strip, or when you merge them together, you get something, in that case, fairly ridiculous. So I think we'll stick with the yin-yang as a better representation of the integration. Okay, so this bifurcation that was taking place doesn't have to be there, right? And again, that's what we're trying to find ways forward. So this statement could be reversed, and there is this natural disposition through which these contraries interact, and that interaction is spontaneous and continuous. That sounds like we're talking about sustainability, right? Sustainability is something that is spontaneous and continuous, and in fact continuous because it is spontaneous. And then the last little line on the Eastern way of thinking is the idea of materialization without matter, and this idea that there is no longer the need to have that external third term, that observer, to support the relation between the object and the subject. And we can do that by recognizing that those two contraries form on their own a self-sufficient configuration. And then therefore the propensity that stems on its own from their interdependence orients this process of reality. So in other words, and this is another one of these lines that I keep thinking about over and over again, it's true, and like what do you do with something like this, but the idea that there's materialization without matter. So it's constantly the process of materialization, the process of becoming that is really relevant here, not the matter, not the being, not the focal end point. Okay, so why are networks important? Well, conceptually they are one way to represent this continually connectedness, and practically I like to believe that by analyzing networks you may be able to help avoid some of the unwanted or unexpected consequences, because we all know that most of the environmental problems we have today are actually the results from solutions from trying to solve earlier problems that we had, and we didn't understand the indirect effects and the unwanted consequences. And my research, my colleagues and myself, in starting with ecological network analysis, have kind of more broadly defined what we do in terms of energy network science. And again, recognizing that we're dealing with open systems where there's flows of energy, matter, information. We represent either ecological systems, earth systems. More and more we're looking at economic systems, social systems, financial systems, and how that energy and matter is used within those systems, urban metabolism studies, for example, to quantify these direct and indirect effects in the system. We do believe that the networks are a universal language that can be applied to many different systems out there. And in addition to the flowing and the openness that is taking place in terms of the energy, matter, and information, it's something about what is the organization of those structures that is important. And there are commonalities out there, right? So for one thing is we see these branching patterns, we see these fractal images that appear in nature, and we also see them in healthy functioning social systems as well too, that you have branching patterns as being we already saw some slides earlier today that showed some of those power law relations in city size as well too. Okay, and this book has been mentioned a couple times already this morning as well, and we know that this is one of the first attempts to really look at a global model that integrated with feedback population and agriculture production, industrial production, renewable and non-renewable resources and so forth, and highly influential. I think, brilliant, important work that came out here, but not having the impact perhaps that it should have, because it was seen as, for one reason perhaps, by the economists and the politicians as too gloomy, as not being very uplifting. People don't like to hear about limits, and even though we know that there are limits out there. So there have been many follow-up studies to this as well, and one of the things I think that Jane Jacobs said very nicely is that we need to consider these natural laws that are out there are not merely limits, they're invitations to work along with them. And so then taking that concept, we can think about when nature's been working along with them for quite a long time, 3.5 billion years or so of life on this planet, working within these constraints of how much solar radiation there is, how much nutrients are available, what is the ability for waste to be reassimilated into the biosphere, and so forth. So again, this idea of what are the insights we can learn from ecosystems, and then hopefully maybe design social systems in a way that is benefiting from that knowledge that we have. And so some colleagues and myself just recently came out in July, we published a new book called Flourishing Within the Limits. And the idea there is to recognize again that there are biophysical limits. I think that that's probably important, and maybe still some people will have trouble with that, but I think that's quite clear. But how do you flourish within these? Right? Ecosystems are highly diverse and complex and beautiful and wonderful systems that are all flourishing within these limits. And so what we did is we identified what are known to be about 14 different properties of ecosystems. And I won't go through all of these right now, but they start with things like the laws of thermodynamics, which are obviously necessary conditions, and go through things like hierarchy and the features of complex adaptive systems that Simon touched on today. And then we took these 14 principles and we essentially looked at how could we apply these to social systems, and kind of recreating the original limits to growth model, found some win-win solutions, found some solutions where if we incorporate these, then we would be maybe not sustainable, but much better off than we are now, and at least along the way towards being sustainable. So which brings us to this question is, what is sustainability? And it's a big question, and there's a slide that I oftentimes have and I had taken out, and after hearing Wolfgang's presentation, I wish that I would have had it, because, and this is maybe my personal belief that is a minority, but I think there's a big difference between sustainable development and sustainability. Sustainable development is a beautiful concept that the Brundtland Commission and Bill Clark's work here before that did as far as what are human needs and human desires. To me, sustainability is a systems property. It's not about what humans want at all. It's about what the system is doing in order to maintain itself, and that could be a human system or not. It could be a natural system that doesn't have humans at all in it. So I know the cat is already out of the bag on that one as far as redefining sustainability versus sustainable development, trying to be precise in their uses, but it's something that I think about a lot and try to really, I think it's important to make that distinction. So in other words, I'm trying to think of what are the system properties that make a system sustainable. And again, it's back to this idea of becoming, not being. It's a property of the organization, the configuration, the disposition. It's the something about that structure that allows those self-organizing adaptive properties to continue. And while it's an open system to energy and matter flow, it's a closed system operationally. I think this is one of the things that we understand about these sustainable systems now, is that this idea of operational closure is that the results of systemic operations are at once more systemic operations. So you're getting a continuation because what is happening is actually closing such that it can happen again in either later place or later time. So this idea of autopoiesis and self-organization is key here. So these function systems, they are operationally closed, but they function in a way that allow this self-organization to happen. And there's some things about systems that we're still trying to understand how that works. I mean, that's very much an open and interesting area of research, right, to understand how these systems are able to do that. One of the properties that I think is also key to it is this idea of structural coupling. And that is when you have a state in which the two systems shape the environment in such a way that both depend on the other for continuing their autopoiesis and increasing their structural complexity. Well, that sounds a lot like that yin-yang that we were talking about earlier too. But we see that in nature, this codependence, this coevolution, this reciprocity that is going on continually allows the systems to function. And so I would even build my definition of sustainability on continuing functioning structural coupling, right? And they're all kind of vague words perhaps, but I think we can actually build a science off of this. I think that this is something that is first principle oriented and basic enough about how systems are actually able to do this. And this work is actually coming from Niklas Luhmann's work, who, if you know, he's a social scientist, and so he was working in a far different field, but brilliant systems thinker. Okay, and then I'll introduce one other of my heroes in the systems thinking world is Christopher Alexander, and I would strongly recommend his work as well too. He was an architect. He was born in Vienna. He was a trained architect, spent his career in the US, and the language that he uses is about centers. And so it's essentially the system that we were talking about earlier, but he says centers are the fundamental primary entities. A center is any zone of coherence that occurs in space. It may arise initially as a minor non-homogeneity in space through differentiation, but then each center is recursively dependent on other coherent centers for its own coherence, which sounds like mumbo jumbo the first 3 times you read it, but then it starts to make sense, I think. And so, again, it's about this recursiveness, reciprocity, that the center is dependent on other coherent centers for its own coherence. It's, again, that interplay, that trade-off, that relationship, that context that allows that center to function. And then he goes on to add that it's not just about the coherence, but it's the ambiguity is an important role there too, that he's saying that some centers will share parts of other centers, or the wholes will overlap with each other. And so there's this ambiguity there that each one can be seen as combining with this one or that one, and each one is being shaped by its neighbor. Well, if that's going to happen, if there's this neighborhood of interplay, then it's also very important to maintain yourself within all those disturbances, within all those pulsings that's going on. So if here we have one center, and I've represented it as a self-organizing autocatalytic feedback of the simplest kind, three compartments that are continually reinforcing each other. So this could be one center, but what he's saying is that there's other centers in that same neighborhood that are out there also centering and being centered, I guess. But then those are overlapping and they're open to exchange such that there might be these additional connections taking place there. So now A1 has the opportunity to continue its original cycling, but it also has the opportunity to join another cycle. So when that happens, then of course A1 doesn't want to lose its original identity of being part of Team 1, and so what Christopher Alexander had proposed was that one of the real important properties was structure-preserving transformations. In other words, these transformations being the connections with the rest of the neighborhoods, that it must preserve its structure and its own coherence, right? It can't get lost in the neighborhood that is around there. Okay, well that makes sense. That's one of the things we try to do, is when there's change and when there's disturbance, we want to maintain and be resistant to any potential change that could affect us. But he said, well, that's not really enough. That wouldn't be a sustainable system in the long term if all of it's doing is kind of like hunkering down and resisting transformation. So he added this other one, which I also think is really brilliant. He's saying that what's really necessary is it's wholeness-extending transformations. So the transformations are at the same time preserving the structure but opening to those further transformations that allows then the network to gain from the coherence of the other centers around it. Right? And so that's the trade-off that we're talking about, the trade-off between preserving structure, being resilient within one center, but then also being open to the transformations of the neighbors that are around you. And so, yeah, I think that's also strikes me as we're on the way to understanding sustainability if we understand better how systems are actually doing these kinds of activities. So the key then really is forming and maintaining self-sustaining cycles, I would say. So we've got open systems. If that stuff just passes through very quickly and immediately, then it's not going to be a very sustainable system because it always has to go out and find new resources, right? The open system that is not recycling anything. So a little bit of recirculation helps, But then, you know, the last one, the self-sustaining one, is where you've really got these tight coupled reinforcing cycles that are going on there, minimizing. You always still need to recharge it with energy due to the second law, but at least you're getting maximum bang for that. And again, within the ecological literature, we have different ways of measuring ecosystems in terms of their organization regarding the amount of stored energy, the amount of energy through flow, the amount of, you know, we use terms like exergy and emergy and other interesting energetic concepts as well too, but there are ways of measuring the degree of that cycling and organization that occurs there. And so then the other thing is not just doing it, of having self-sustaining cycles, but doing it at various scales, right? So we see that life does that as well too, and here's just an example of a local economy might be very small scale where pretty much everybody knows everybody else. A more intricate economy still has recirculation, but at differing scales, and then what you want to avoid is that bubble economy, which is then, you know, too much dependence, but then no buffer as well too. Okay, so in conclusion then, I would say that sustainability, you know, is a property of these interaction networks. Trying to link together these processes that are positively reinforcing, properties like self-organization, autocatalysis, and so forth, many different names to describe, I think, basically the same process. The closure will lead to niche extensions in creation, so where the diversity that we see coming from is from these new opportunities, this openness to extending your opportunities. And then nature provides a template for design for this. So I know there's a big rise in the field of biomimicry as a design application for specific technologies. But I think more generally at the system level, we can see how ecosystems are able to continue to function sustainably over vast periods of time and incorporate those ideas into human systems as well too. So they're open systems, but they're behaving in a self-organizing, sustainable fashion. So I'd even leave you with one more Jane Jacobs quote, another hero of mine. Take-home message: all self-sustaining systems are reciprocating. 1969 she wrote there, right? And she was talking about cities. She was already taking the insight from urban complexity and urban dynamics and building sustainability concepts. Okay, so we're going to need these ideas that we're all working on. Unfortunately, we have some giants that we can stand on, so we can stand on their shoulders and maybe see far out there. So that's all I had.